All right, you're good to go. Thank you.
Good afternoon, everybody. So welcome to our presentation, Enhancing Discovery and Preservation, leveraging, oh, I can't see that. Leveraging AI and machine learning in Oklahoma State University Digital Archives. I'm Max Prudhomme, and I'm joined today by Jivitesh Venu and Irania Papu. We're both graduate students. So next slide. So first, I'd like to begin with that this project aims to automate and enhance the discovery of archival materials using advanced machine learning techniques, such as facial recognition, to preserve and categorize large-scale digital content. So the main objectives have been to deliver a trainable facial recognition model capable of handling any photo of any format. And then I'm referring to the Oklahoma State University photo collection, large collection that basically represents the institutional memory. The closest, like alum, faculty, any events on campus that includes individuals as well as anything that happens at a like animals farming, aerial photographs, buildings, etc. Anything at a land-grant institution. Ultimately, we're looking into enhancing the quality of the metadata, filling in gaps, improving model accuracy, and improving the discoverability. So to make this possible, we're looking also makes it possible to, in terms of discoverability and accessibility, to build a robust and dynamic user interface, which will allow users to interact with the system more effectively, and will be accessible from one central point. The project falls under the broader umbrella of artificial intelligence, with the focus being machine learning, particularly discriminative models like facial recognition. We are to create a model that is both scalable and accurate, paving the way for future improvement and integrations within the archives management system. Next, I would like to, my grad assistant, Jivitesh, Irania will continue the presentation. Thank you.
Thank you, Max, for starting us off. So let's take a closer look at the flow and architecture of the project, which is designed in 4 main stages: data input, data processing, data storage, and user interface. The data process starts with adding new images to the system. These images are digitalized form of the historical photographs from the OSU archives. Next is labeling the metadata. After this process, the metadata is labeled. If the metadata is not available, the model will help us to fill in the gaps. Next is the processing phase. The labeled images, whatever the labeled images are there, they are processed by using the Python scripts. For this, we are also using the facial recognition model, which generates the embeddings of the face, which are then stored in the database. These generated embeddings are subject to the clustering algorithm, which are then stored in the database with the corresponding embeddings after subjecting them to clusters. The images and their corresponding metadata are then stored in the image pool, which is then integrated with the UI. Okay, as you can see here, the UI is, it has mainly 2 features. One is the image search, the other is the name search. For the image search, users upload an image and the Insight Face model processes it to find similar faces in the archives. This allows users to efficiently locate images of individuals from historical archives based on the facial similarity. For the image search, users can simply type the name of an individual and the system retrieves the images associated with that name from the labeled dataset. Now, let's look at the progression of the model, how the image search happens. So basically, the process starts with a large image dataset, which consists of a collection of historical photos, each stored in its respective directory. The next step involves running the facial recognition algorithm. For this, we have used the inside face model, which can detect multiple faces in an image. As you can see here in the middle of the slide, after facial detection, the model identifies individual faces from the photos, which are then used for further processing. This is a crucial part of our pipeline as it enables us to isolate each face for recognition and embedding generation. Once the faces are detected, we generate the facial embeddings. Each embedding is labeled with an identifier as shown here in a JSON style structure. Here, each face is tagged with its name, location in the dataset. They allow us to compare and match faces with the dataset even across different images or variations in the lighting or orientation. Finally, the embeddings along with the image labels are stored in our database, which enables fast searches when the users upload a new image or enter specific metadata. The system can quickly compare the embeddings and return similar or identical results from the archives. This progression from dataset to deduction in embedding generation and data storage creates a seamless and efficient process for managing and retrieving large volumes of historical images. Next part of the project will be explained by Jivitesh.
Yeah. Thank you, Hiranya, and hi everyone. So, Hiranya explained clearly about the progression part. So, then we are now going to discuss about the labeling tool. So, the labeling tool is another important aspect of the system. It is built using the tkinter library, which is available in Python right now. So, the purpose of the labeling tool is to label the images. So, adding an identifier to them and moving them to the reference set. So, the input to the labeling tool are the clusters. So the clusters is a phenomenon of grouping a similar items together. And here we are using a facial recognition model. And by then we are extracting embeddings of the faces and grouping them together. So in result, we have cluster folders with all the similar faces of a person. I mean, the different versions of a faces of the same person in one folder. And the input to the labeling tool is these cluster folders. So the tool displays the images from the clusters, and each cluster contains images of the same individual person. So thus, users which are using this tool can able to navigate between the images and assign and modify the labels. The tool also retrieves the corresponding names and predefined CSV files that are attached to these images, and the maps identifiers for specific subjects. And once if the image is identified, that name is a label to our entire cluster folder, and all the images have been automatically assigned with the appropriate label and saving the time for the manual labeling process. So this is especially useful for handling the huge chunks of data that we are working on, especially for the images and archives. And additionally, um, we use a TB-scan clustering algorithm to cluster these unmatched faces. The purpose of the clustering um, plays a key role in here because there are so many group images we have with numerous number of faces, and we have only parse metadata so that we cannot able to identify the specific person. So once the labeled image uh, is identified, I mean the person is identified, the user can save and move to the next image. So this can improve the labeling efficiency of the large data sets. So the labeling tool has been provided with the appropriate buttons for the respective actions. So all these activities that are occurred in the labeling tool are stored and in a log file just to making sure like the logging process because if there is mistake happens, we can able to retrieve back by using the logging file. The next, we go through the significance of the model. The day by day, we are the data we're working on is increasing, and probably to be precise, the historic collection of the images that we're working on often lacks structural metadata, complicating person-specific searches. So our facial recognition pipeline improves searchability and retrieval accuracy of the images. Since we have labeled the images and moved them to the reference set, they are stored uniquely in the database as shown in the progression slide. So now when a person types an image, we are using another index library searching algorithm to specifically search the corresponding name and retrieve the corresponding image for the person. Right now, we have analyzed over 47,000 images and more than that, and we have detected 14,894 unique faces among them. Means there are so many multiple images of the same person. And of these 14,894 unique faces, right now we have successfully identified 4,291 individual faces right now, and we have moved them to the reference set. And due to the model, we can able to identify this, and the labeling tool helped us to improve this drastically. This system and pipeline enhances the organization and accessibility for future research and archival use. Next, we're going through the challenges that we have faced. So, since that is a huge chunk of data, we require strong computational power and storage capacity. So, these are the basic challenges that we have for computation. We have included large-scale batch processing techniques, and also we implemented thread pool techniques to implement parallel processing of the batches, just to ensure to run the processes parallel in a time, so that you can able to use the GPU and CPU that we have to the utmost extent. So GPU helped us a lot actually. And for storage, we are trying to use and there's a decision that is going on between the operational storage and the cloud due to the large volume of high resolution images and due to the archival policies. We are confined to the operational storage right now, and we may be moving on to the cloud for further in future. And for scalability, ensuring the solution is adaptable for different data sets and the systems by implementing a universal approach for the facial recognition and image search. And we're going on to the next slide, follow-up work. And the major part of this project is to improve the identification of the individual persons. So in order to do that, we need to improve the labeling reference set. And in order to improve the reference set, we need to go through the labeling process. So first, we will continue the labeling of the new single person's images, and they are added to the to the data set, and we ensure the data set remains up to date. And second, we plan to validate of the work. We plan to validate our work that we are going to do. And if the person is labeled wrongly, we need a person from a team just to make sure the label was correct or not. So the metadata would be so much precise, and we can able to rely on the data that we have. Finally, we have ongoing annotation process of the photographs, and the records will continue and further improving the metadata, ensuring that archival system remains as an accurate and useful process as possible. And we have followed certain differences, and that has been discussed in the next slide. So the corresponding differences that we have followed, and thank you.
We have a few minutes for questions, if anyone would like to put any questions in the Q&A for our presenters. Just a reminder, all of the slides will be made available after the conference, so in case you missed anything. Okay, thank you everyone. We appreciate your presentation.
Thank you very much.
Thank you.